everyone, and welcome back. So we're on to our next, our second try at using Amplify, and I hope that it's been pretty easy for you guys to log in and such through Google. So again, if you click on the Google link attached to this assignment, it should bring you right to Unit 6, Chapter 1, Lesson 3, with the warm-up about El Nino. So yesterday you did the first lesson, and prior to that you did the pre-unit and the readings and vocabulary quiz. You should notice that a lot of the vocabulary words are kind of reused because we're kind of towards the end of the year where we're trying to pull things together to understand how energy is moving on our planet. So today's focus is how energy is transferred to air. When we take the temperature outside, or when we take temperature in general, we're looking at the air temperature right above the ground, almost right at level of where your hands are and what you can feel. So what I need you guys to do is to get onto Amplify. There we go. Get onto Amplify, and you should be on this page on the warm-up. And what it's asking you is to look at the graph here. I'm going to overview this. Look at the graph, and during El Nino years in Christchurch, New Zealand, it goes down 1 degree, meaning that it's cooler. So El Nino events occur every 2 to 7 years. This is a shift in the climate across the tropical Pacific. If you don't know what tropical Pacific is, it's a region in the Pacific Ocean. We're going to look at a map tomorrow and we'll talk more about this region. But if you don't know what it is, essentially it's just a place in the Pacific Ocean that that you'll find places like Australia, New Zealand, even, you know, any of the Pacific Islands and stuff like that. So we're gonna go back to this area tomorrow. And what we're looking for is what causes areas when they're in El Nino to become cooler than usual, and some areas actually become warmer. But in this specific case, we're talking about Christchurch, New Zealand, which actually gets cooler. So if Christchurch, New Zealand air temperature is cooler than usual during El Nino years, this means the air has either more, less energy during an El Nino event. So key point here is that we're looking at the energy is going, the temperature is going down, right? So temperature itself is a type of energy. It's thermal energy. Well, it's a measurement of a thermal energy. And if there's more energy, that means it's hotter. If there's less energy, it's cooler. So if we're seeing that it goes from 12 to 11, which is going down, becoming cooler, it would indicate that there is less energy. When you're done with that, I would like you guys just to click on next activity. I'm going to go back to my slides right over here, and we're going to move on to this. So we're going to be doing an investigation question, and sorry about that. And what we're trying to focus on is how does air get energy? Now, I've already preset 2 claims to kind of guide you into the idea and direction of what I'm trying to get at. So we know that if air is getting energy, right, it has to be transferred because it can't be created or destroyed, so it has to be moved. And the word transfer, which is a word that we've been using all year long, is to move from one object to another or one place to another. And on Earth, 90% of our energy originates from the sun. And if we're talking about heat, most of the time we kind of connect it to the sun. And so what we're trying to find out right now is how does energy get from the sun to the air? And right here we have 2 claims. Claim 1 is that energy is transferred from the sun to the air and continues downward. Now, this is a logical understanding of it. And essentially what's happening is the sun is heating up the planet and it trickles down onto our surface. Our second claim is a little more complicated, And it's the idea that energy is transferred, energy is transferred from the sun down to the ground, and then from the ground, the heat is bounced back up into the air. Now, may not be as logical, but the idea might make some sense because of some of your experience. We know that as we go higher in the troposphere, it may not be as hot. So we want to figure out which one of these claims makes more logical sense. And to do so, we're going to set up an experiment, which I will exit the slide and go into a live viewing in just a few minutes. But essentially what we have here is that we have an energy lamp. The energy lamp that I used was from a heat tank that you use for animals that need to be in hotter weather. So essentially it does give off heat. Nowadays, most light bulbs will give up way less heat because they're designed to be energy saving. But the lights that I used for this experiment are used to replicate sun heat. Then we have two options. Option one over here is that there is some air and rocks. So essentially this is, if there's the ground, what happens to the air right above it? And then on the other side, we have no surface. So it's just air. We're not even, there's no interference from the ground. So we're going to see if the ground makes a difference in gathering energy or creating more heat, in other words. So if we were to think about this, if claim one were true, where that the energy is transferred from the sun to the air, both the air above the rocks and above this no surface should be exactly the same because the energy is trickling down. Claim 2 would mean that the air above the rocks is hotter because what happens is that the rocks take it and bounce it back up into the air. That can't happen if there's no surface. So we're going to see which one of these claims has any evidence for it. And I'm going to cut into my video. We're going to cut into the video right now.
Hi guys, I'm here with Sprinkles. This is really a low budget film with an A-star actress who did not want to be in the film. Sprinkles, come back. Come on. Okay. Come on, Sprinkles, over here. Come on. Science with Sprinkles. All right. Okay, so we had some budgeting issues and it didn't fit Sprinkles' need. But we can at least do the experiment, which is also very low budget. I didn't have a lot of the materials I needed, so I had to jimmy rig a couple wires and a couple pieces of yarn. But it should still work. So what we're trying to test is if the air above the rocks or the air above nothing is hotter. So what I'm going to do is I'm going to take the temperature of before for both cups, which is 20 degrees Celsius. I'm going to have to talk to the manager about the heat in this building. 20 degrees Celsius. And again, 20 degrees Celsius. Obviously, both of these have not been under any different conditions besides the fact that they are one with rocks and a surface and one with just air on the bottom. So what I've purchased is this lamp. Okay, got to jimmy rig it again, guys. All right. It's all about the video editing. Okay. So, Sprinkles helped me do this by doing nothing. So, what we're going to do here is we are going to turn this light on, which will actually give heat as if it was a sun. So this is a light that gives off heat similar to the sun. It is used for heating up animals such as iguanas and other lizards. So what we're going to do is we're going to leave it for about 10-15 minutes. And when I come back, we're going to see if the air inside of this area or the air inside of the rocks is hotter. Sprinkles, come here. Come here, girl. she won't be in a B budget movie, but we'll be back.
Okay, everyone. While we wait for the experiment, we could put in that the starting air temperature was 20 degrees Celsius. Again, we're using Celsius because this is a science class, and that is the universal measurement in the science community. What I'd like you guys to do is click next. We're going to come back to that page to fill it out. Don't worry. And we're going to predict, we're going to kind of try to answer using a simulator how this is going to play out. So I predict that the temperature will increase for both after about a minute, mostly because there's a heat lamp. But we're actually not going to use the heat lamp to kind of get information right now. We're going to wait, and we're going to use the simulator just to do that for now while we do the experiment. And what we're actually looking at is we want to look at the surface test because we're looking at this kind of information. And I'm going to let it play out for about a minute. And if you realize that the energy is coming down from the sun, but bouncing up. So it's going 13, 14, 15. And what's interesting is once this becomes hotter, it goes back down. But for the most part, the energy let me reset this. The energy is coming from the sun and bouncing back out. And what happens is the temperature from the land is hot and it's heating up the air above it. Water is going at a little bit of a slower pace, but that's okay. What I'm going to look at now is what happens when there's no surface. And as you see, the temperature never changes. So this kind of supports claim 2, that the idea that when there's a surface, the energy, it's hotter above. Because here it's going up probably like to about 15, 16 degrees. Whereas here, with no surface, the air is just -10, below freezing, and never changes. So if I go back to this area right here, the test actually showed that the air temperature when there's a surface increased, but the air temperature stayed the same after about a minute. Now we're going to see if this this idea that the surface is hotter when there's a the air is hotter with the surface when we get back from our experiment.
Hey guys, so we're back 15 minutes. With a little bribing, I got Sprinkles to stay with a pillow. And some belly rubs. She agreed to be in a B budget movie. But we're back and we're going to test the temperatures. Well, we had a little bit of a delay, obviously. Okay. All right. But it's a good time to check the temperature. So let's go ahead and check these temperatures. And the one with no surface is 25 degrees. So it did go up 5 degrees from the heat lamp. Now, the one with rocks and a surface went up to 31 degrees. So even more so. We're going to talk about what this means when I get back to the slideshow.
Okay, so we were here when we left to go back to the video and to the experiment. What I would like you guys to do is go from 3, go back to 2. And I'm going to click on next. Okay. So we had 20 degrees and the final air temperature was 25. And that's a difference of 5 degrees Celsius. The second one with the rocks, oh, sorry, this is the one with the rocks. This is the one. There we go. So with the surface, it got all the way up to 31 degrees, which is a difference of 11. When there was no surface, it only got to 25, which is still an increase, but only an increase of 5 degrees. It probably increased mostly because the heat lamp was much hotter than the temperature around, But I predicted if I left it on, it would probably stay around 25 degrees. So with surface, it increased 11 points. Now I'm going to click hand in and go back to here, revisiting claims, number 4. So click on 4 and click next. So now let's look back at this idea. We have two options. Both the simulator and the experiment showed us that when there's a surface, right? When there's a surface, the sun hits it first and the air above then gets hotter. You need a surface to take the heat and then release it. When there's nothing for the sun to hit, there's no surface, the heat is not being trapped. So this would actually support claim 2. Energy is transferred from the sun to the surface, and from the surface bounces back up into the air. And what evidence supports the claim? If you look at the data table, it shows that when there was a surface, it increased 11 degrees. When there was no surface, it only increased 5 degrees. So this would show you that, this will show you that when you have a surface, it actually takes in the heat and lets the heat go, whereas this doesn't actually follow that idea because it didn't increase as much as this one. Next lesson, we're going to go over this idea a little more. But for now, you should look and see this idea. Press hand in, and it should then go to the homework. Before we go on to that, I want to go back to our slides. If you get any idea, the main idea from today's lesson was energy from the sun is transferred to the surface. Some of that energy then gets transferred to the air above the surface. So, key concept. The energy from the sun hits the ground first and then warms the air above it. This makes sense because if we look at this diagram, I'm going to go to the one that zooms in. When we go up higher in our atmosphere, it actually gets colder. So it would make sense that the ground gets warm first, and all of that energy is then transferred back into the air. And just to complete the lesson, we have the homework question. Read the statement and decide if you agree or disagree. The sun warms the air directly. Now, if we go back to our claims here on 4, we realize that our claim actually says that it doesn't warm the air. It warms the ground first. So you can actually just copy this, Control copy, and in your homework, write I disagree because it warms the surface first. And then you can just paste your evidence. When you're done, you can click Hand In, and you will have your homework done for the day. Thanks, guys, for watching, and I hope you guys enjoyed sprinkles.